So we have two types of pipes in physics. We have open pipe and a closed pipe. An open pipe is open at both ends, open pipes. Then a closed pipe is open at one end and closed at the other end. The total length of an open pipe is the length of the air column. In this class, we'll be looking at closed pipe. Look at this. Now, look at this. This is the total length of the pipe. Let me label it as X. The length of water inside the pipe, let me call it Y. The length of air column, let me call it A. Please listen attentively to this. In a closed pipe, you don't have business with the total length of the pipe. You don't have business with the length of water inside the pipe. Are you getting it now? You only have business with the length of air column inside the pipe. Is that got to now? Let's say the total length of this pipe, X, is 30 centimeters. And the length of water inside the pipe, which is Y, is 15 centimeters. What is the length of air column? Our length of air column, which is A, will be X minus Y. Isn't it? That is what? 30 centimeters minus 15 centimeters. And that gives us what? 15 centimeters. Is that got to now? Now, look at this. For us to determine the length of a pipe, of a closed pipe, our length equals to, if you look at this thing very well, it is equivalent to what? 1/2 of a circle, right? 1/2 of a circle in a closed pipe is equivalent to lambda over 4. If we have a wave-like movement like this, this is a crest, this is a trough, isn't it? The distance between one successive crest and one successive trough is a wavelength, isn't it? Now, a crest is half of a circle, a trough is half of a cycle. Is that got to now? And one complete cycle on a normal wave represents one wavelength, which is a full distance between a successive crest and a successive trough. But in pipe, one complete cycle is lambda divided by 2. Are you getting it now? So if one complete cycle is lambda over 2, then a semi-cycle will be equivalent to lambda all over 4. I hope that is clear. So that is how what is obtained in pipes. Now look at this now. This is half of a cycle. We now want to make our L the subject of the formula, our lambda the subject of the formula. Our lambda here will be equivalent to 4L. Is that clear now? If a question gives you lambda and asks you to calculate the length of the air column, you are going to make use of this formula. Let's say your lambda is 20 centimeters, that's your wavelength, and they ask you to calculate the length of the air column. It is going to be L equals to lambda over 4, and that will be 20 divided by 4. That will be equivalent to 5 centimeters. Is that got to now? If a question asks you to calculate the wavelength too, you make use of this formula. Is that got to now? But there is actually some other thing we can get from here. What is the relationship between V, F, and lambda. Can someone tell me the relationship that exists between wave speed, frequency, and wavelength? V equals to F lambda, isn't it? Lambda equals to V, sorry, F equals to what? F equals to V over lambda. Now, if we bring F naught here, because this is the first position of resonance in a closed pipe, so its frequency is represented as F naught. Is that got to now? If we bring F naught here, our F naught will be equals to V all over lambda. But don't forget, we've defined our value of lambda to be what? 4L. So our F naught will be equals to V divided by 4L. Is that got to now? So this is the frequency of the first harmonic of a closed pipe. Let us look at the next position of resonance. We can also have something like this. You'll get it clearer now, don't worry. So the water level has dropped down further now. This is the tap to run off water inside the pipe. We now have something like this. The length of air column is this. Don't forget, I already told you we have business with what? With length of air column, isn't it? Yeah. If we look at this very well, it is different from this. Yes. Is that clear? Here, we have only one half of a cycle. Here, we have one half of a cycle and one complete cycle. And I told you, half of a cycle represents what? Lambda over 4. So this is lambda over 4. Let's divide this complete cycle into 2. Lambda over 4 again. Lambda over 4. For us to get the length of the air column, how many lambda over 4 do we have? 3. Lambda over 4 plus lambda over 4 plus lambda over 4. What is the LCM? The LCM is 4. That is lambda plus lambda. L equals to 3 lambda all over 4. Isn't it? Can we actually make lambda the subject of the formula? 4L equals to 3 lambda. Then our lambda equals to 4L all over 3. Is that good to know? But at this point, let's bring the frequency here is F1. That is the frequency of the first overtone. I'm coming back to that. So our F1 equals to V all over lambda. But what's the value of our lambda here? 4L over 3. So, but lambda equals to 4L all over 3. Our F1 will now be equals to V divided by 4L all over 3. Where do I see this division sign? This is V. This division sign is what I bring up here. This value of lambda is what has changed to 4L over 3. I hope that is clear. Yes. So in that regard, our F1 will now be equals to V multiplied by 3 over 4L. It is very simple. Whenever we are changing sign, the numerator and the denominator will swap each other. Is that good to now? So our F1 will now be equals to 3V over 4L. Are you getting it now? Can we actually establish a relationship with F naught here? Don't forget, our F naught is what? V over 4L. Are you getting it now? So, meaning that we can actually bring F1 is now equals to 3 multiplied by V over 4L. Do you agree with that? 3 times V, it will give us 3V. Yes. Then all over 4L. You will now say our V V over 4L is the same thing as what? F naught. Isn't it? So our F1 is equivalent to 3F naught. Are you getting it now? Yes. And in the real sense of it, this is how our F1 looked like. See. Our F1 is like this. Just only one half of a cycle. F naught, sorry. Our F naught looks like this. Just only one half of a cycle. But for the case of our F1, we have one half of a cycle and one complete cycle, isn't it? Now, if that should be the case, how many half of a cycle are we going to see here? Is 3. Can you now see that we are going to have 3 of F naught in F1? Is that good to now? Now, let me now tell you something. For F naught, we only have one half of a cycle, isn't it? Yes. One half of a cycle represents one harmonic. Is that clear now? So, F naught represents first harmonic of a closed pipe. We got the harmonic from the fact that an half of a cycle is equivalent to one harmonic. Half of a cycle means one harmonic. Complete cycle is equivalent to one overtone. Is that got to now? If you look at this, we have 3 half of a cycle or one complete cycle. So this one, in terms of half of cycles we have, we can call it third harmonic, or what is the overtone? First overtone. Is that got to now? Half of a cycle is the number of the harmonic. Complete cycle is the number of overtone. There is no overtone here. We only have first harmonic. Yes. But here, we have one complete cycle, one half of a cycle, making a total of 3 halves of a cycle. That's why we have third harmonic. And one complete cycle, that's why we have first overtone. Is that good to now? So look at the next position of resonance now. The next position of resonance, which will be our F2. Here. How many half of a cycle do we have? 1. That's lambda over 2. Complete lambda over 4. Complete cycle is what? Is equivalent to lambda over 2, right? Lambda over 2, lambda over 2. Is that good to now? So, because it is 2 half of a cycle, that is lambda over 4 in 2 places. So, if you want to simplify this, we have lambda over 4 plus lambda over 2 plus lambda over 2. Our SCM is 4. 4 in 4 is what? 1. 1 times lambda. Lambda plus 2 lambda plus 2 lambda. Our L equals to what? 5 lambda over 4. So, if we want to make lambda the subject of the formula now, 4L equals to 5 lambda, then lambda equals to 4L all over 5. Is that clear now? Now, let me explain something here before diving into frequency. How many half of a cycle do we have here in total? This is 1. Complete cycle will give us 2 half of a cycle. That is 1, 2, 3, 4, 5. Are you getting it now? We have 5 half of a cycle here. We can call this one 5th harmonic. Then how many complete cycle do we have? 2. Or we call it second overtone. Is that got to now? So, now what will be the frequency? The frequency of the second overtone now, F2. Are you getting it now? So, our frequency of the second overtone will be, our F2 will be equals to what? V over lambda. But don't forget, our lambda here is what? 4L over 5, isn't it? So F2 will now be equals to V divided by 4N over 5. That will be V multiplied by 5 over 4N, isn't it?
Yes.
V multiplied by 5. 5V over 4N. Are you getting it now? But we can as well say that our F2 equals to 5 times V over 4N.
Yes.
Isn't it?
Yes.
But don't forget, this V over 4N is still our value for F0.
Yes.
So our F2 now equals to 5F0. Let's check if that claim is correct. In our F0, we only have 1 half of a cycle. But in our F2, how many half of a cycle do we have? 1, 2, 3, 4, 5. Is that good to now?
Yes.
The next thing I want to also tell you on closed pipe is that this open end, this wide open end, is called an antinode. What do I call it? An antinode. This wide open end is called an antinode. This is another antinode. This is another antinode.
Yes.
Then this junction is called a node. Is that clear now? In this pipe now, we have 3 open ends. That is 3 antinodes. And we have 3 nodes too. There will be a node here too. 3 nodes. The junction, the intersecting point here is the node. The open space is the antinode. Is that good to now? So that is it. In our next class, by God's grace, we are going to talk on open pipes. Have a nice day.